Okay, chapter 3, periodic table. So, in chapter 2, you learn about electronic configuration. So, from electronic configuration, you can figure out the position of the element in the periodic table. Okay, so in periodic table, we have S block, D block, P block, and F block. So, this is something new for you. Okay. Okay, so first from electronic configuration, we can figure out period. So period in Malay is kala. Period is something like this. Okay, from left to right. So basically there are 7 periods in periodic table. Okay, so based on the electronic configuration, how to determine period, we need to look at the highest value of n. So here is 1, 2, so highest value of n is 2, so period number 2. So based on this electronic configuration, the highest value of n is 3. So based on this one, the highest value of n is also 3. So for this one, the highest value of n is 4. So to determine period, we need to look at highest value of n. Even though the highest value is in the middle, not at the end. Okay, so highest value of n determine period. Okay, next is block. So we do have S, D, P and F block. Okay, so how to determine block? Block is determined by the last electron. So we look at the end of the electronic configuration. So this one is S block, this one is S block, this one is P block, so this one is D block. So you look at the last electron. Okay, so S block is basically metal, group 1 and group 2. P block, most of the element in P block are non-metal. D block is a transition metal, and F block we rarely see this one, okay, because most of the element are radioactive. Okay, lanthanide and actinide series. Okay, next we look at how to determine valence electron and group. So in order to determine valence electron, you need to determine block first. Different block, different way to determine valence electron. So the easiest one is S block, because in S block, it only have 2 groups, okay, which are group 1 and group 2. 1 valence electron, 2 valence electron. So this is S block. How to determine a block is depending on last electron. Okay, depending on last electron. So S block, S block, S block. 1 valence electron, group 1. 2 valence electron, group 2. 1 valence electron, group 1. So this is the valence electronic configuration. If the question asks you the valence electronic configuration, so your answer is 3s1. So this is the valence electronic configuration. Same goes to this one. 2s2, 4s1. Valence electronic configuration. Configuration only for valence electron. Okay. So why group 1 is ns1? Because all element in group 1, so in group 1, the last electron, okay, or the valence electronic configuration is 1s1, 2s1, 3s1, 4s1, 5s1, 6s1, 7s1. So the general valence electronic configuration is ns1. Same goes to group 2. It is ns2. So group 1 is alkaline metal. Group 2 is alkaline earth metal. Okay, so next is D block. Okay, so for D block, we need to add on electron. Okay, 2 plus 1, 2 plus 1 is 3. So 3 valence electron, group 3. 2 plus 2, 4. So 4 valence electron, group 4. So for D block element, it starts with group 3 until group 12. Okay. Okay. So if you look at this balance electronic configuration, so the s orbital is full. Okay, the s orbital is full. However, the difference is at d orbital. 1, 2, 3 until 10. So the maximum number of electron can occupy d orbital is 10. So that's why D block stop at group number 12. Okay? Okay. So how to determine block? We look at the last electron, D block, D block, D block. So how to determine valence electron at D block element? We need to add on 2 plus 6 is 8, group 8. 2 plus 5, 7, group 7. 2 plus 5, 7, group 7. So if we look at the pattern, 4s2, 3d6, 4s2, 3d5, 5s2, 4d5. So the valence electronic configuration, the general one is ns2. So the s orbital has 2 electrons. Okay. For D, it is n minus 1. D 1 until 10. Okay, so that one is for D block. Okay, for P block, okay, for P block element. Okay, so all of these comes from P block. So for P block, in order to determine the valence electron, we need to add number of electron at the highest value of n. You need to add on number of electron at the highest value of n. The highest value of n is 2. So 2 plus 4 is 6, group 16. Okay, because P block element start with group 13 until 18. Okay. So the highest value of n is 3. So 2 plus 4, 6, group 16. Highest value of n is 4. 2 plus 3, 5, 15. 2 plus 4, 6, 16. 5 plus 3, 2 plus 3, 5, 15. Okay, so for P block element, the general valence electronic configuration is ns2 and P1 until 6. So the maximum number of electron can occupy P orbital is 6. Okay, so if we look at here, so for this group 17, the valence electronic configuration is ns2 and P5. Okay, we need to add number of electron at the highest value of n. 2 plus 5, 7 valence electron, but then in group 17. Okay, so when you have 3 valence electron, maybe it is in group 3 or 13. 4 valence electron, group 4 or 14. So how to know? You need to know the block. So that's why in order to know group, you need to know block first, valence electron, then you can figure out group. Okay, so we look at exercise. Okay, so for the first one, period is highest value of n. So for block is last electron. So in order to determine group, you need to know valence electron first. Okay, so valence electron is 1, group 1. So period 3, the block, the last electron is at P block. So 2 plus 4, 6, group 16. Okay, so the highest value of n is 3. So P block, so 2 plus 5, 7, group 17. So the highest value of N is 4. Okay, so these are D block element, last electron D block. So 2 plus 1, 3, group 3. Okay, 3 valence electron, group 3. So this one, period 4. So 2 plus 4, D block element. So 2 plus 4, 6, group 6. Okay, so the last one is P block element. So we need to add number of electron at the highest value of N. So 2 plus 5, 7, group 17. Okay, so period is always the highest value of N. 4, 3, block is the last electron. Group is depending on block, s orbital 1 or 2. Okay, so valence electron 1 or 2 for s block. Okay, next we have all the information here, so we need to know what is the electronic configuration. So based on the data here, we can know the valence electronic configuration. So the highest value of N is 4. It is at S block, so group 2. So this is the valence electronic configuration. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So next, the valence electronic configuration is 4s2. So this is D block, okay? 3d, 10 valence electron, 10 minus with 2, 8. Okay, because we need to add on number of electron, okay, to figure out valence electron. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. Okay, next. So the valence electron, 5 valence electron, period 3, p block. So 3s2, 3p3. Okay, 2 plus with 3, 5. 1s2, 2s2, 2p6, 3s2, 3p3. Okay, so for example, if I take titanium, okay, I do the electronic configuration. 1s2, 2s2, number of electron is 22. 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. So 10, 22. So if we look at the electronic configuration, okay, so this element come from D block. So we add on 2 plus 2, 4 valence electron, group 4. So group 1, group 2, group 3, group 4. Okay, so if I do nickel, okay, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, okay, 3d, 20, 28. Okay, so D block element, so 2 plus with 8, 10. So nickel is in group 10. 10 valence electron, group 10. 5, 6, 7, 8, 9, 10. Okay. Okay, we try to do for oxygen. So oxygen 8 electron, 1s2, 2s2, 2p4. Okay, so P block, we add on number of electrons. So 6 valence electron, group 16, 13, 14, 15, 16. So oxygen is in period 2. Period 2. Okay, so period 1, period 2. Okay, why don't we try for aluminium? So 1s2, 2s2, 2p6, 3s2, 3p1. So P block, period 3. So 2 plus 1, 3 valence electron, group 13. Okay, so electronic configuration can figure out the position of the element in periodic table.